Okay, so all of you can aware about the sorry, all of you aware about our subject, main subject. Just, so subjects of this course, it is switch mode power converter, and subject code is EE6443. Okay, so before starting any of the topic, okay, so we need to aware about the what is the motivation of this subject, means why that subject is important. Okay, so that we need to know first. So basically we are going through a subject and don't know about the motivation. So what is the meaning of this study? Basically we are offering the subject that is power electronics and drives. Okay, the PG in power electronics and drives. So you know that power electronics is the specialized subjects for an electrical engineering curriculum. Okay, so why that is important? So before that we need to know about what we need to know about the motivations. I think all of you are aware about the analog electronics. Okay, so basically, what is the difference between the analog electronics and power electronics? Okay, and why that subject is more important? Okay, so why the electronics has come to the market? I think all of you know about it. So basically, electronics devices having very less losses. Okay, as well as other efficiency also be there. Okay, if you see that in our plus 2 level, so initially we are going through different we are going through that diode, then tetrode. Okay, so that before semiconductor devices, okay, we are using some uh, tube devices. Okay, so that also working as a diode, mean rectifier, but it having huge power loss, huge complications, as well as the efficiency, energy efficiency was also very less. Okay, so that's why gradually they are obsoleted. Then the analog electronics has came. Okay, so you can understand that after that the semiconductor devices came. Then what are the dopings of there? Okay, based on the doping you can also specify the range of operations of those devices. So gradually the technology are gradually improved, as well as you can get the different good devices of our application. So why that power electronics converters? Okay, basically if you see that analog electronics, if you know about the analog electronics, digital electronics, there is some limitations. Okay, that all are semiconductors devices, but in digital electronics you can normally, if you see the different literature means different reference books and these different reference papers, so you can see that digital electronics normally we are using maximum giving some voltage in 5 volt range. Okay, maximum you can see, and in case of analog electronics normally we are using 15 volt. Okay, but very less point also be there, means not more than 20 volt, maximum we are getting 15 volt. Basically that 15 volt you say like the bias voltages. Okay, like in op-amp circuit you are giving some in op-amp circuit you are giving some bias voltage. Okay, so that so op-amp circuit you are giving some bias voltage like plus VCC or minus VCC, that range. Then if you see some transistor circuit, okay, so that also having some bias voltage. If you see most of the cases all are in 15 plus minus 15 volt range. Okay, so that's why you can conclude that in analog electronics the voltage level is not more than the normally it is 12 volt, 15 volt, sometimes 5 volt, but not more than 20 volt or 24 volt, like that. Okay, so if you want to use such thing, means diode rectifier in our power line. In our power line means our domestic application, where actually we are power electronics engineers, means we have to design the everything as per our consumer end, as per our domestic application range. That side of range we have to do something. Okay, so we have to do some converter, we have to design some converters. Okay, and we have to working with those converter, and that can be used in different manner. Okay, so as per your application range. Okay, basically anything has been designed as per their application range. Okay, so if you see that how much voltage range for our domestic end means, normally we are using 50 hertz in Indian culture, 50 hertz, and that is maximum 50 hertz for single phase, 230 volt or 240 volt. Okay, so that I am telling about that analog electronics, the diode rectifier. I am taking one example, 1 in 4007 or 1 in 4001. That last digit, that 7 and 1. Okay, that two are the example of a signal diode. Okay, that also been using as in rectifier bridge, but in case of where, in case of analog circuit, in analog circuit sometimes required some rectified AC, means some DC value, rectified DC or pulsating DC values are needed. So that case you will get it. Okay, so that amount of that case you will get it, that rectified means DC. Okay, so by using that 1 in 4007 or 1 in 4001, that 7 and 1 stands for the maximum voltage withheld by the devices. So 4007, that 7 means only 7 volt, it will working up to 7 volt. But if you want to rectify the your power line voltage, okay, power line AC voltage for driving any DC appliances in your home, so what you need to do? That voltage range is around 230 volt, and that voltage range is 230 volt, and that value, okay, and that value is coming 230 volt 50 hertz. Okay, but that common devices, that common analog devices are not able to work with that range of voltage. So what we need to do, we have to fabricate or we have to design some special type of diode. Okay, that diode is called the power diode. I am taking some example, that is MUR diode, MUR diode, MUR460 or MUR150. Okay, different voltage range, that values are different. Okay, so MUR460, maybe it is, I think it is that specification is quite higher than MUR150. Okay, one is maybe 500 volt or 4 ampere. Okay, 460 maybe 600 volt 4 ampere, and MUR 150 means it is 500 volt 1 ampere. I think so. I need to cross check it, but that in my mind I am telling you. Okay, so I think that's the rating. Okay, so you can understand that how much voltage level, the voltage level is more different. Okay, voltage level is more different than your analog devices. So that's the main purpose of that power electronics converters. Okay, but this course is only designed for switch mode power converters, means where the power converter. Okay, I am coming another points. Okay, so that I think all of you are able to understand the basic difference between the analog electronics devices and power electronics. Basic thing is that the power level is different. Okay, and for making the difference you have to use some other type of doping. Okay, sometimes more layer of that dopings are required. Okay, so more density of doping also been required sometimes. Okay, so that will be discussed in constructions, means power electronics device constructions, maybe one topic of your power electronics converters, but that is not covered by these courses. Okay, so from that point of view you can understand the basic differences between the analog electronics and power electronics converters. Okay, now what we will do, so what is the motivation of this subject? Okay, that means what is the difference between normal power electronics converters and switch mode power electronics converters. Okay, so I am telling about in my just beginning of that lecture that we are giving more trust on that. We are giving more trust on how to minimize the losses of the system. Okay, that's why we are shifting that tube-based devices, shifting from tube-based devices to the semiconductor devices. The main motivation was that energy efficiency, how less efficient, okay, how less energy how less power losses you can be designed for it. So optimum power losses thing you can be designed for it. Okay, that's a basic motivation. So normally we are going that in by using different switchings. Okay, we can also get it from different switching techniques. Okay, very commonly I am telling about for the very generalized idea on it. Okay, so normally what we are doing, so we can use as a switch the devices just like a switch. Okay, just like a switch means what is the purpose of our switch in our domestic, means in our home we can see that we are using some piano type of switch. Okay, piano type of switch means just on and off. It's the switches are look like the piano keyboard keys of the piano, that's why it is called piano type of switch. Okay, so when you are making it on, okay, so that maybe the light will be turned on or fan will be turned on. Okay, when it is off it will be off, means fan will be turned on. Means on means circuit is connected, off means circuit is disconnected, means only two modes of operations, on and off. So that's why it is called switching mode. Okay, switch mode. If you are using those devices, power devices, just like a switch, it may be on or it may be off. There is no intermediate state in between on and off. Okay, that's why it is called switch mode devices. Okay, switch mode of converters. So here we are discussing such type of converter that's only behaves like a switch mode of operations. Okay, that's why that title topic subject name is switch mode power converters. Another thing also be there, why that switchings are important. If you see, normally we are discussing about the, when we are discussing about the transformer, we are telling 2 points. One is that power level. Okay, primary side means LV side, means low voltage, or sorry, low tension, LT side, and high tension. High tension, both of the same, both of the side the power range will be same, means not range, power is constant. Okay, as well as your frequency also will constant. These two things are maintaining fixed for the transformer. So not like only transformer, in conservation of energy point of view, the input power, input side energy and output side energy both should be constant. Okay, so you know that energy is an integrating factor of your power. If you multiply the time with your power, you will get the energy. So both side what happen? Energy, input side energy and output side energy, both side energy will be same. Okay, it's an integrating factor. You can also say like that, power into time equal to power, input power into time equal to output power into time. Okay, both of the end. Okay, time duration may be different. So basic conservations is that both of the side power of the both of the end should be making constant. Okay, so power is fixed. Okay, so what is the power? Power equal to coming like that, voltage into current in very crude method. Okay, when switching on, that I am telling about the energy efficiency. Okay, that means power is less, there is a less power loss. How it is coming in switch mode power converter, power is less. Okay, there are two types of power converter, switch mode power converter, another is linear mode power converter. That also been discussed in some of the classes. Okay, gradually I am coming one by one. Okay, so power equal to voltage into current. Okay, if switch is turned on, means what? Currents are flowing. Okay, currents are flowing, that means most of the currents are flowing. Okay, so both of the end is shorted, that's why currents are flowing inside of the switch. So if the both of the end is shorted, so maximum current will be flow with the minimal voltage. What is the minimal voltage? In ideal cases you can consider just like a zero voltage. So what is the power? P equal to V into I. Voltage is, these two are the short path, short circuit path. So 0 into I, whatever current is flowing through the switch, so power is 0, means power loss is 0. Okay, same thing also happened when the switch is off. When the switch is off, how much voltage is there? Maximum that potential, maximum voltage will be there. Whatever voltage you are applied, okay, that parallelly it will become across to the device, so maximum voltage. And how much current will be there? It is open circuit. In ideal case I am considering that current is 0, voltage is maximum, means open circuit voltage there, that definitely maximum, and the current is 0. So what will be the multiplication? Again you are going for that multiplication, so you will get that again power loss is the 0. That's the beauty of that switch mode power converter. So any of the point of view, you are making that switches power loss is 0. That is the motivation of this subject. Okay. So another technology also be there, that also we discuss. So there are some different, I have already discussed two things. Okay, that power converter dynamics devices, that device should be covered in your power electronics converters subjects, that is your preliminary subjects. Just for a moment. Hello, hello, good morning. Like class is going on now, all the students have joined. I have mailed through the Nitris portal. The code is also be there. So what is the problem? Rest of the students are joining. MS team में क्यों show होगा? You please talk to your supervisor how to join in the group. Okay, you please talk to him. What is your name? Abhishek Kumar. So who is your supervisor? Who? Call? So you talk to him. Please talk to him. I'm in the class. I'm in class. Okay. You call me later. Okay. Okay. So another thing is that, so two things. So the power electronics devices means, if you want to know about the devices, the characteristics, that definitely covered in power electronics subject, that is a core subject. So what are, in these subjects I am also giving very small touch about what type of devices like power MOSFET, power BJTs, just the structure, not in very details. Basically that subject is designed basically on the modeling, how do you going to be modeling of the switching devices, it means, sorry, switch mode power converters, not other things. Okay, and the control structure, how you are going to design the controllers for this one. Okay, so we are giving more trust on these two portions, and the magnetics of the device and circuits. Okay, these portions are means design point of view, how we are going to design the switch mode power converters, that we need to be followed. Okay, we are not discussing about very basic physics about this one. Okay, that's why another subjects also be there, and another switching methodologies, there are different switching methodologies. Okay, and discussing about very common things, that switch mode power converter, another is that is called that zero voltage and zero current switching. Okay, so what is happened in those cases? So zero voltage and zero current switching means you are turning on, you are fixing up the logic in such a manner. So you are going to turn on your switch when that voltage is zero. Okay, when your voltage is zero, current having some value. Okay, so what will be the means benefit for it? So basic benefit is that voltage is zero, means zero voltage switching, voltage is zero, current having some of the value, so multiplying them. Okay, so 0 into something, voltage is 0 and current having some value, so multiplying both of them means you are getting zero power loss, and zero current switching means the same concept. Okay, so current is when your switch will be turned on, only the current is zero. Okay, so that is called ZVS and ZCS. Okay, that is called soft switching techniques. Another one is normal conventional one, that is called that hard switching techniques. Okay, so soft switching technique, so another less our losses will be there, and that's points, that's switching techniques and the regarding the converters. Okay, that type of converter will be discussed in your coming semester one subject. Some advanced power electronic devices are there, that will be discussed over there. Okay, so total different theories, different subjects are there, different topics also be there, so that will be covered in different way. So it's a post graduation course. Okay, in normally what happen in BTech, we having only one course of power electronics, and we have covered lot of things, that the DC-DC converter, DC-AC converter, different things will be there, the AC-AC converters, some basic idea on it. Okay, so but this entered first year will be based on the cases, you know, that we are giving more trust on that different types of subjects of this specialization. So different subject cover different thing in advanced level. Okay, so basically the motivation of this subject is that we are going to discuss about different modeling, Okay, different calculations of the switching methodology, sorry, due to mathematical steps, how we are going to be model of the switches, what are the different mathematical techniques are there, okay, modeling techniques are there, and how we are going to be design the controllers. So practically they are working on it. That's the motivation of this subject. So I think all of you able to understand what is the motivation of these subjects, why it is important. That I am also telling that different power loss concepts, different point of views are there. Okay, not like only power loss concept. That is another important issue. I am asking about the linear power supply. Okay, linear switching converters, sorry, linear converters. In this case, linear converters, what happened? Switch mode power converters, I am telling that all the cases devices are the same. Okay, means if you are using diode means power diode, all the cases you are using power diode. If you are using power MOSFET, all the cases you are considering, just for taking an example. Okay, for what happened in case of linear devices? Okay, so linear converter, so we are using same switches, but that linear power converter there was working in that quasi hello, huh, huh, अच्छा, इनवैलिड कोड क्यों दिखाएगा, बाकी लोग तो ज्वाइन कर गया, ठीक है, अगेन आई विल शेयर टुडे अगेन आई विल मेल थ्रू नीट्रिस, ओके, ऑल ऑफ यू प्लीज ज्वाइन देयर, ओके, अभी चल रहा है, right now the classes are going on, okay, if you want to code again you please also mail me, again I can share through the mail also, okay, mail me, okay, when you mail me, right now you are mailing, okay, mail me that after the class I will give you the code as well as I will send it again through Nitris portal, okay, so please cross checking it, it should not be the invalid code, I think there is some other problem. All the students are there, they are attending the class. If it is invalid, how they are attending? Okay, no problem, again I am sharing. Okay, so I think all of you are able to understand that why means what is the motivation of subjects, why it is important. I was there in linear converter. In linear converter, what happened? That switching devices are there, that power electronic devices are there. They are working in quasi-linear zone. Quasi-linear zone means you know that if you see that IV characteristics, so some of the portions are nearer to the I, some of the portion is nearer to the V. If you are considering as a switch mode power converter, okay, so either that one point stands on the I, V will be 0, ideal cases, or either some of the points means V is there, I is 0. But in quasi-linear zone, what happened? They are working in between I and V. Means if you that remember that one from the basic electronics, that if you draw the curve IV, that if you cross that points, operating points curvature you are drawing, so you can see that point is there in between, means in between I and V. So that of the any of the points you having some values of V as well as I, so definitely there is some power. Okay, so power losses means I square losses will be there, okay, or VI losses will be there. So that's why they are working in the linear zone. Okay, so more energy losses will be there in linear power converter. Okay, but high power application, that converter also been used in different way. Okay, so that's the point of view, basically what is the motivation of this subject and how we are going to be implement. So how we are going to be implement means there is another some approaches also be there, like stability approach. Okay, stability approach means what? Okay, so there are different types of stability. One is called load regulations. Okay, two things are there: transient stability, another is steady state stability. Okay, so transient stability is there related to the control dynamics. How sophisticated controller you are going to be used over there. Okay, means how control principles are associated with your switching devices, switching circuits. Okay, so that transient stability depends upon your control structure, what type of controller you are using. Another one is steady state stability. Steady state stability means that related to how regulated devices, sorry, how much regulations you can achieve from your proposed switches, proposed converters. Okay, there are different types of converters. Okay, so how your systems you are going to be designed, so means how your regulations, okay, how you are able to design the optimal regulation of your system. There are different types of regulations: input voltage regulation, load voltage regulations, another is temperature regulations. There are three types of regulations: input regulation, load regulation. Input means line regulations, load regulations, another is temperature regulations. Means what do you mean by the input regulation or line regulation? Any kinds of disturbances are there in your input side, but your output voltage will be altered, unaltered. Okay, means it is not changed without having some range of operation definitely there. Okay, you are designed for the 5 volt device, 5 volt converter, and you are giving 50 volt. Definitely output will not work. Means you are not getting any output. Maybe if your system will be damaged, basically range of the voltage decide that how much voltage means how what is the specification of your switch. Okay, what type of switch you are using. You are designed for 5 volt. You can use maximum 50 volt switches, but if you are giving 50, so if any spike is coming beyond 50, so your switch will be damaged. Okay, so you have to design everything as per your rating, as per your specifications. Okay, so that's the thing. So how they are related, so one by one I will discuss. What will be the basic structure of the switching converters, what are the different modeling techniques of the switching converter, how the model, why that modeling is also important. Okay, and how the controller will be designed. And magnetic circuit means if you know that normal ferrite core normal ferromagnetic core we are not able to design for it, so we have to consider for the ferrite core. What is the range of switching frequency based on the data sheet we are designing everything. Okay, I think all of you will to understand the motivation of this one. So after that we have to design about the syllabus. Okay, there are 6 modules. Okay, so first module means cover the overview of your switch mode power conversion. Okay, and introduction of DC-DC converters. Especially switch mode power converters are working on for DC-DC converter. Another one is AC-DC converter. Sorry, DC-AC converter, that is inverter. Inverter portion will be covered in your advanced power electronics devices. Means next semester like multi-level inverter. Okay, and DC-DC converter. Sorry. DC-DC converter in this semester we are covering about the non-isolated type DC-DC converter, and isolated type DC-DC converter will be covered in your next semester courses. Okay, so basically we are using the switch mode power converter for DC-DC converter. We are giving more trust on it and our designing portions. Okay, then module 2 is the power semiconductor devices. That I told you that very basic thing I will be discussed, but not in very deep. Basically we are giving more trust on modeling of the converter, like module 3. Okay, modeling of the converter, that covers the modeling of DC-DC converter, state phase representation, circuit averaging method, state phase model of the switching converter. Okay, that module 3 and module 4 both are very important. Okay, then we are going for that control designs. Okay, for our switching converters, like what type of controller we are designing, pulse width modulations. Okay, controller design for principles, common practical control applications, controller and the sensing circuit, regulations, voltage and current control method. That are the very important things. Module 5 is the basis on the design of magnetic designs. Okay, so what are the different types of ferromagnetic ferrite cores? Is it E type or EI type? What are the types, or toroid type? What are the materials, and how do I pick the materials, means select the materials. Okay, for winding means how to design the bobbins. Okay, so not sorry bobbin means how to design the number of turns. Okay, based on the inductance, the calculation of the inductance, then calculation of the selection of the gauge. Okay, gauge means WH. Okay, so how we are going to design them, so that will be discussed in module 5. And finally, one design example. If you have some, if you are giving some specification for the converter, so how would you design one switching converter in closed loop? Two things are there, open loop system as well as the closed loop. Okay, so closed loop converter, how we are going to be designed. It may be some simulation will be there. Based on the simulation, we can also discuss. So I think all of you are able to understand what is the syllabus of our subjects and how we are covering them. So what are the most important books are there that is written here? Okay, all of you please noting down it. Okay, what are the important books? After that, I will giving some instructions about the subjects. Okay, means the methodology, teaching methodology. Okay, so I will discuss about it. Also, I will share that I am recording the session. Okay, I have also shared the recording to you. Okay, in there are two official group. One is MS Team group, as another one is that WhatsApp group. Okay, any kinds of information need to give, so I will send it through the WhatsApp. So one of you pick means you can select yourself from the CR of the class. Okay, I regularly communicate with that person. Okay, and giving some most important instruction to the students, so that students can convey that message to your friends. Okay, so one person need to be selected as a seer. Okay, as a seer, that I need to next class you please finalize me who is your class here, so I can give some most important instruction to them. So what are the books we need to go through for essential reading? One is very common book, that is Net Mohan book. Okay, so power electronics converter application design by Net Mohan and Underland and Robbins. Next one is that Ericsson book, Fundamental of Power Electronics book, Ericsson and Maximovic. Okay, next one is the Philip T. Crime. Okay, Elements of Power Electronics by Philip T. Crime. These three books are very core books, not like only switchboard power converter. If you follow these three books, another one is Rashid. Rashid book also very important. That name is not, I have forgotten to mention over here. Rashid book also very good, but we have normally gone through it in UG level. Okay, so you can follow these three book also, that can also cover the Rashid. Okay, but main thing is that you have to follow these three well renowned books. Okay, so that can not like only for these subjects. If you purchase this three book, that can help you other subjects also. Okay, and supplementary reading, you can also following some of the books that I have been mentioned over here. Okay, so after that, the important instructions for this class means how the class will be going on. That's the most important issue. Normally, you know that I have already means how do I design the course. Okay, so you can see that there are 6 modules. Okay, so all the students are advised to prepare 2 copies. One is your classwork copy, another one is your homework copy. So what is the purpose of the classwork copy? So whatever I am means basically online mode of learning is there. So most of the cases you see that the slides will be there. Okay, most of the cases you can see follow my slides. Okay, the slides I am discussing here. Okay, you please noting down important points from my slides. Okay, after completion of the course I will share the slide. Okay, so what you need to do in your classwork copy? So you need to write whatever I am teaching here. You write those things. Okay, you please write down important notes. Okay, and what you will do in your homework copy? You will prepare a fair copy. Fair copy means whatever this means topics is discussion in the class. Okay, so you have to go through from these 3 books. Okay, and prepare a fair copy note. Okay, based on it you have to prepare the note. Okay, so with the regular interval I am asking to submit your classwork copy, date wise classwork copy. So whatever you are taking the note, you please mention your date for classwork copy as well as homework copy. All the cases you need to prepare your date. So with the regular interval after completion of the module 1, I am asking for to submit your classwork copy as well as the submit of your homework copy. I want to see that what is your progress, what you are noting down in my class and how you are preparing your class. Okay, based on your preparations, copywriting, okay, presentations, okay, and numerical analysis, numerical problem practice, okay, that carry some marks. We're having some TA marks, okay, so that TA marks will be decided some factors. Number one factor is your class attendance, okay. Every day I will take the attendance and I will download that who are attending regularly attending my class, okay. So some points will be there, some marks from your class performances, attendances, then that is comes in your class performances. Then assignments with regular interval. I am giving some assignments that you need to do it in your homework copy and submit. I am give date will be given. Okay, from my side, the CR will collect everything. Okay, class note, homework copy, and I directly communicate with the CR. CR will send it to me. Okay, so some point marks will be there from your class performances. Class performances stands for your attendances, class attendance, then assignment submissions, then class note submission, homework copy submission, and finally class test. Okay, with regular interval after completion, maybe half of the module. Okay, so means I will discuss. I will announce for the for taking class test. Okay, online class test will be there. So based on it, your TE marks will be evaluated. Okay, so that will be given at the time of end of your semester. Okay, so my suggestion is that regularly you should update yourself. Okay, do not waste your time by doing any means rubbish job. Okay, give your more trust on these subjects. That is very interesting subject. Like power electronics, dye specialization, those are coming from the sense. Okay, so that is very interesting subject. If you are able to learn these subjects in future, we will be benefited. Okay, so in there will be discussion modeling of the basic converter. In future, if you want to do in this converter topology work, okay, that will help you for how to modeling those topologies. Okay, those are especially for the research purpose. So power electronics dye means we are doing post graduations, means our mentality is that we can converge. Okay, we can convert our work in the research domain. It may be in R&D sector, it may be in teaching sector. Okay, whatever sector you are going, means R&D sector means you can also join to the industry. Industry having some R&D sector. Okay, if anybody absorb you, okay, so they can directly work on that R&D of that industry, and other person those are interested for teaching, they can also come in. Okay, so that's why the subject is very important and you have to work on it. Okay, you have to study is very minute. So that is enough for today's discussion. Okay, so